Hello, my name is Jeff Passmore. I work for JDSU's sales support organization, and I will be your host today for the second of three videos covering the HST's TDR. Today's video will cover Auto ID TDR. HST, for all practical purposes, has two distinctly different TDRs built into it. What I mean by that is one is Auto ID, which is sort of like can be thought of as autopilot on an airplane. Minimal input from the user, very few things to set up. TDR does all the quote unquote thinking for you in terms of analyzing the return trace. Now that's in opposition to the manual mode TDR. What I tell technicians, the two couldn't be much further apart. Manual mode is like you crawling into the cockpit of the airplane and flying the plane yourself. If you don't like a particular setting, you don't like the way something appears on the screen, it's entirely up to you to change it. Now, there are several additional functions available under manual mode that are not available under Auto ID. So what we find is that the more experienced users gravitate towards the manual mode, where the less experienced users, they're pretty happy with Auto ID. So to start the TDR up, let's select number 4 from the main menu. And we know instantly upon entering the TDR whether or not we're in Auto ID mode. Because if you are in Auto ID, it says so right across the top of the screen, TDR Single Pair Auto ID. Now, if you did not see the qualifier saying that you're in Auto ID, that would simply mean you're in manual mode. So TDR Single Pair indicates that you're in manual mode. So the way I initiated Auto ID, hitting F2, the Actions button, and just selecting number 6, Auto ID. I'm going to go ahead and run one for you first, hooked to nothing, just so we can discuss the screen and the layout and what the different indicators are on the screen. So to initiate the test, we just simply hit F4, the Start TDR button. Auto ID TDR mimics what an experienced TDR user usually does. What I mean by that is an experienced user will pre-test the line first to see what type of trouble they're looking at before putting the TDR on it. The reason for that is they want to see if their trouble falls into that preferred or non-preferred category that we spoke about earlier in the TDR introduction. So the pretest data is fed to the TDR's algorithm or math problem, and then the TDR will eventually pop out with an answer. So since we're not hooked to anything, there is no fault indicator on this result. But as I said, this is just to step through the screen and to point out certain things. So top and left and right-hand corners of the screen are two distance markers. That represents the amount of real estate the HST thinks is showing you. The flat horizontal line in the middle of the screen is the return trace itself. The bump over to the left, or the hump up bump, however you want to refer to it, is the launch pulse, or where the energy is actually leaving the TDR. It's also associated with a term called blind spot, which we'll talk about when we cover the manual mode operation. In the middle of the screen, there's a vertical dotted line. It's the distance cursor. Its position on the screen corresponds directly to the box in the bottom left-hand corner labeled C1 or cursor 1. So right now my distance cursor is placed at 5,490 feet away from the tester. There are two ways to move the distance cursor. Way number 1 with either the left or right arrow keys. You see, as I move the distance cursor to the left, the C1 box gets bigger. That's just to enable you to see it a little easier. So that's way number 1. Way number 2, let's say I have a distance in my mind for whatever reason. One of my friends said, hey Jeff, check it at 1,000 feet. I could simply reach down and type in 1,000 using the keypad dialer. So just start typing on the keypad dialer. Once I press OK, the cursor would be snapped to the number I gave it, in my case 1,000 feet. Now, how accurately that number or that cursor is snapped to the number that you type in is all a product of the range and resolution that you're in. Speaking of range, in the bottom right-hand corner, you'll see that I'm in long range. Auto ID TDR starts in short and stops in whatever range it detects a problem in. Well, since we were not hooked to anything, it just stepped its way all the way out to long. The middle box, labeled TVG Adjust, TVG stands for Time Varying Gain. It's a patented process by JDSU. All it wants you, the operator, to do is set that number to the dominant cable gauge you think you're working on. You do that with the up and down arrow keys. As you press either the up or down arrow, it takes about 1/4 of a second for the change to register, but you'll see that I move up 1/2 a gauge at a time. The reason for that is you folks are always telling us you're on mixed gauge cable, right? TVG Adjust goes no higher than 26.5 gauge and no lower than 21.5. So if you're on a piece of 19 gauge cable, just leave it set to 21.5. You'll be just fine. And lastly, there's a box in the bottom right-hand corner of the screen, a miniature box. That little box is called World View. It's actually a viewing aid intended for manual use, or in my opinion, it's more apt for manual use. The gray portion of the box is the portion of the screen that is visible on the HST. The white portion of the box is the portion that you cannot see. So let's say that we had a flat line here in the gray, but if we looked out in the white, we could just begin to see a dip up or down. Well, that would just be an indication of, hey, you need to range out a little further. Now, the interesting thing about that box is that it takes a precedent from a graphic standpoint. What I mean by that is it's always floating to the top. Sometimes you could have a case of trouble on the TDR screen that would fall in the vicinity of the worldview box. And it's conceivable that the worldview box could actually cover up part of an event that you're trying to look at. So for all those reasons, we made that box configurable. If you find the configure key right underneath cancel, select it once. That will take you to a configuration for worldview. So select number 1, and you can either show worldview on or turn him off with number 2. Now when I hit cancel, he's gone. Now I often run it without worldview just because I like it. I think it kind of declutters the screen a little bit, but 6 of one, half dozen of the other. Alrighty. Well, now I'm going to hook to an actual a simulator that will simulate what you will see as a user when you hook to stuff outside. Now, the combinations, of course, are endless of what I could simulate, but the one I've got hooked up, hopefully you will enjoy because it points out 3 things, 3 pretty crucial things about the TDR. It illustrates a true strength of the TDR. It illustrates a perceived weakness of the TDR. And then it finally illustrates a true weakness. And you'll see what I mean here in a minute. So I'm going to hit Start TDR. Now, since I'm doing the pretest information, it's a good habit to get into of hooking up both tip, ring, and ground, right? So in manual mode TDR, all it's really necessary is to hook tip and ring up. But since I'm doing pretesting, a ground reference is required. So hook up all 3 leads, then press Start TDR. As I said, that pretest information is fed into the TDR's algorithm, and it assists the TDR in figuring out what it's attached to. Finally, out pops the result. Well, if you remember our TDR introduction, one of the true strengths of the TDR is its ability to locate bridge tap. So the first event right there, you can see is labeled as B tap or bridge tap. Notice also that the distance is also marked for you at 902 feet. Now, that doesn't mean I can't move my distance cursor. I can, but there's really no practical need for it because Auto ID is going to place the distance cursor for you. So, a true strength, bridge tap identification, bridge tap 900 feet. Well, look at the second event. at 1,865 feet. There are 3 question marks above it. Now, as I travel around the United States and train on the HST, some of the areas that I visit, the HST has been in the field for a long time, and when I come to this simulation, I usually get some teasing from the tab. Oh yeah, I see that 3 question mark stuff a lot. Well, here's the way I respond to the 3 question marks. Do you suppose out of the hundreds of thousands of feet of cable that you have in your prospective area, with tens of thousands of different subscribers, all at different lengths and locations, do you suppose I have all those combinations programmed into my auto ID TDR? The answer, of course, would be no. So all the TDR is trying to show you here is, hey, I don't know what's going on, but at 1,865 feet, I am getting a significant reflection back. Now, why is that important? Well, the TDR uses high-frequency energy pulses. What else uses high-frequency energy pulses? Well, how about DSL, IPTV signal, right? That's all high-frequency energy. So as corny as it may sound, you can think of the return trace from an auto ID TDR shot as the road that your DSL signal has to travel down. You want the road with, you want the flattest road, right? You want the road minus the potholes and the big speed bumps. All right. Finally, wouldn't it be nice to see those pretest information or see the results from the pretest information? Right? Well, you actually can by selecting F3, the Results tab, and selecting number 3, the List View. Under the List View, I show you the results from the pretest information and the results from the TDR. TDR results obviously at the top. Well, I promised you a strength, a perceived weakness, and a true weakness. Well, let's look at my TDR pretest results. I didn't have any cross battery there, right? My AC volts were 0, but look at my leakage ohms. Greater than 999 is good, of course, but look at ring ground. Remember when we discussed the ohm meter, we said any value or number that came back without a letter next to it meant that it was really bad, right? So I'm dead grounded on the ring side. Well, dead ground on the ring side is going to significantly unbalance the pair. Well, look at longitudinal balance. 60 or greater is good, 30 is horrible. So those 2 results have just confirmed the other's presence, right? I got a dead ground on one side, I expect longitudinal balance to be horrible, and it is. So, strength, bridge tap identification, perceived weakness, the 3 question marks, and true weakness, it's inability to deal with the ground, because ground isn't mentioned under the TDR results. Okay, I get back to the graph view the same way I got to the list view, just by selecting F3 and number 3, graph. And I'm back to the TDR graph view. Now, a few words on auto ID. To expect auto ID to label everything and to get every fault every time is impractical for the reason that we already talked about. The combinations are virtually limitless when you think about it. I'm okay if I mislabel a fault because really what I'm doing, what comes back from a TDR shot is a string of numbers as long as a football field. We're just analyzing the rise and fall of those numbers in addition to our pretest data to help us figure out what we think is there. Now, I'm okay with the mislabeling of results. For example, if you came to me and said, Jeff, you know, your auto ID told me there was a bridge tap out there at 900 feet, but I went out there, I didn't find a bridge tap. I did find an old terminal splice, though. I'd be okay with that. Now, if you told me, Jeff, your auto ID told me there was a bridge tap out there at 900 feet, and I went out there and I didn't find a thing, now you've got my attention. The reason being is that the reflected energy it's pretty hard for it to lie, right? It's pretty hard to ignore, for the machine to ignore X amount of reflected energy being bounced back towards it. So if you think along those lines, I think you'll understand where I'm coming from. I'm much more concerned about my device telling you there is a reflected event and you go out there and find none. That would be troubling as compared to me perhaps mislabeling a result. All right. Well, that pretty much concludes our second segment on TDR, Auto ID. I certainly hope you enjoyed it. And we'll also hope that you will join us for part three when we cover the manual operation. So thanks again, and we'll look forward to seeing you in part three.